Today we're going to be talking about triangles and relationships within the triangles where we can talk about inequalities. So the first is this fact. So this is a relationship that's true for all triangles. The longest side is always going to be opposite the largest angle, and the shortest side is always going to be opposite the smallest angle. So if you take a look at these two pictures, you can see in the one on the left that the longest side is the one that's highlighted in red, and opposite that is the largest angle in that triangle. Same thing with the shortest side. So if you look at the picture on the right there, you can see the shortest side, which is highlighted in blue, is across from the angle in the triangle that is the smallest. Take a look at example 1. You are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 27 feet long, the left slope is about 24 feet long, and the right slope is about 20 feet long. You are told that one of the angles is about 46 degrees and one is about 59 degrees. What is the angle measure of the peak of the mountain? Now, drawing everything out, we're told the bottom edge is 27 feet, the left slope is 24, and the right slope is 20 feet. So that's all drawn in there. Now, because you know two of the angles, 46 degrees and 59 degrees, you can determine what the last angle measure is by subtracting 46 and 59 from 180, and you get 75. Now, since you know that the largest angle should be opposite the longest side, the longest side is 27, that must mean the largest angle, which is 75 degrees, must be the one across from the 27-foot side, which means that the angle of the peak is 75 degrees. So in terms of answering this question, the correct answer would be C, 75 degrees. All right, take a look at example 2. List the sides of triangle RST in order from shortest to longest. Well, we see that the smallest angle here given is 29 degrees, so the side that's opposite that is going to be the shortest side, so that would be ST. The next one would be the 30-degree angle. So the side that is opposite the 30-degree angle is the next shortest side, which would be RS. And that leaves us with one last side, which is RT, which happens to be opposite the 121-degree angle, the largest angle. So RT must be the longest side. So from shortest to longest, that would be ST, then RS, and then RT. All right, example 3. In triangle PQR, list the angles from smallest to largest. So this time, instead of being told the angle measures and listing out the sides from smallest to largest, now you're given the sides and you're going to list the angles from smallest to largest. So we see the smallest side, the shortest side, is QP, and opposite QP is angle R. So angle R must be the smallest side. And then now we go to the side that's marked 7, that's PR, and across from that is angle Q, so angle Q would be next. And then lastly, we have the side that says 8, which is QR, and that's opposite angle P, so angle P must be the largest. So this would go, the measure of angle R is less than the measure of angle Q, which is less than the measure of angle P. All right, the next theorem we're going to talk about is what is called the triangle inequality theorem. Now, just because you have 3 segments does not mean that you're able to form a triangle with those 3 segments. So what this theorem says is that the sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. So take a look at this picture here. What this theorem says is that AB plus BC has to be greater than AC. AC plus BC has to be greater than AB, and AB plus AC has to be greater than BC. So all of those must be true in order for you to be able to form a triangle using those particular segments. Take a look at example 4. A triangle has one side of length 12 and another of 8. Describe the possible lengths of the third side. So we're going to let X represent the length of the third side, and you can draw diagrams to help you visualize whether X is the small or large value And we're going to use the triangle inequality theorem to write and solve inequalities to help us determine the possible lengths of that third side x. So let's say that 12 and 8 are the larger ones given. So 12 is the longest side. Then that would mean that x plus 8 has to be greater than 12. So that means that x has to be greater than 4. Now let's say on the other hand, let's say x was the longest side. Then that would mean that 8 plus 12 has to be greater than x. So anytime you're writing these inequalities, it's always two of the sides in the triangle. When they are summed up, they should be greater than the third side. So that means that x must be less than 20. That means that third side has to be greater than 4 and less than 20. So somewhere between 4 and 20. Let's do another example. A triangle has one side of 10 centimeters and another of 14 centimeters. Describe the possible lengths of the third side. Again, we'll let x represent the length of the third side, and we'll write some inequalities. So we would say, okay, let's say 14 was the longest side. That would mean that x plus 10 has to be greater than 14. In solving that, we get x is greater than 4. Now, if x were the longest side, then 10 plus 14 has to be greater than x, which means x must be less than 24. So x has to be more than 4 and less than 24. Otherwise, there is no way for us to create a triangle using these measurements.